right, guys, we are practicing our entrance card from yesterday. And the goal yesterday was to have normal distribution application problems. So Emma and Lauren are up here to help us. Please listen carefully. Remember, I'm taping, so your voice will be recorded. It can pick up anywhere in the room.
Start off by taking as this is greater and subtracting the mean from it. And then put it over 8 because that is the standard deviation, and you get 0.5917.
Lauren, you want to do the other Z-score?
Not really, but okay.
You're doing great.
And then the other one would be 325 minus the mean, which is 304 over 8, which is 0.9957.
Okay, next. So our first step was to find the two, what do we call them? Z-scores. And an interpretation of a Z-score is the exact standard deviations above or below the mean. So we have that in black and red. And now Emma's going to tell us what to do next. Oh, then wait, sorry. Okay, yeah, Emma's going to tell us what to do next.
Now you're going to subtract 0.5517 from 9957, and you get 0.4440.
Okay.
Or I guess was it?
Now, I have a question for the ladies. If I was watching this at home, I'm not sure if you said this on tape. I would look at the black and I would look at the red, and I would think that 0.5517, that 0.9957 is what? What would you might think that is? The Z-score. But is that really the Z-score? No, so that's okay. But let's explain, let's maybe draw an arrow to what the actual Z-score is, what Z is like in black and red, and then we'll talk about what the 0.5517 means. Okay, so what is the actual Z-score that goes with the black one, the top one, guys? 0.13. So just write that Z is equal to 0.13 in black, or green. That's fine. 0.13. And then the Z in the red is what, guys? Okay. Thank you for the many times of repeating. So the ladies did a lovely job. Let's give them a round of applause, you guys. Okay. And now I want to just kind of summarize it again, and then I'm going to ask you to give me a thumbs up to the side or down. So I'm just going to, if you've been gone, first step was find the Z-score. So we found the Z-score here and find the Z-score here. Then we go to the table, we find the decimals. These are called our p-values. Then we subtract our big minus our small. How do we know we subtract? What's our key word? We're finding between. Now, I had a good question that popped up. I said just leave things in decimals. If you wanted, though, if you're curious, like this 0.4440 is a proportion or a probability. And if you want to change it to a percentage, that's fine. You just move the decimal 2 to the right. So there's a 44.4% chance of Tiger getting a drive between 305 and 325. Instead of giving me a thumbs up, thumbs down, I would like you to give me, on a scale of 1 to 10, 10 being the best, how do you feel on this concept? Write it on your entrance slip and pass that entrance slip forward. And get ready for notes. We're passing our entrance slip forward, and we're giving us a score on a scale of 1 to 10. How well do you feel on this concept? And we learned this concept yesterday. I'm going to pause it real quick while we're handing something in. Okay, so again, right now what I'm going to do is I'm going to introduce what we're doing today with just one slide. There's going to be a question on it. It will require your activity or your participation, and it's to prove the reason that we are learning the actual learning target today. Okay. So the question is Mr. Dull came to me and said, Catherine, I need you to figure out how many people love pizza so I can figure out how many pizzas to order for the senior party. Okay, so we're going to pretend you guys are seniors, even though you're mostly 9th and 10th graders, right? So there's no way that I can interview all seniors, right? There's just no way. Okay, so we could put Schoology out. That does have some bias. So instead, I'm going to randomly sample 5 of you. And I'm just going to sample this row, and we're going to pretend you're seniors, okay? So out of this row, will you guys raise your hand and tell me if, like, pizza is, like, if you went home tonight and your parent or grandma or whoever you live with says we're having pizza, you would get excited. Raise your hand. Okay, 3 of you. So that's okay. So row 1, I have 3 out of 5. Well, being a statistician, I'm going to say, well, maybe I'll just try it one more time just to see if I can reproduce my results. Okay, so row 2, I have how many of you in here? I have 6 of you. Raise your hand. Your mom says pizza tonight, and you're like jumping for joy. Raise your hand. 1, 2, 4 out of 6, is it? Okay. It's okay. I'm still counting. 4 out of 6. Okay. Next row. Okay, I'm going to put you boys in with this row because it's only a row of 2. So next row, your mom says pizza and you're jumping for joy. Raise your hand. So these 2 rows together. 1, 2, 3, 4, 5 out of 7. Okay, row 4 is Matthew's row. Okay, jumping for joy. We have 2 out of 3.
I wouldn't be jumping for joy.
But you'd be happy. Okay. And then my last row.
I would be disappointed.
Row 5. Who'd be jumping for joy? It's veggie pizza. No? Okay. It's, 2 out of 5. 2 out of 5.
Sorry, bro.
All right. Ladies and gentlemen, I would love someone to quickly find a decimal for these. So someone in row 1, Vincent, could you do 3 out of 5? Emma, will you do 4 out of 6? Sierra, you do 5 out of 7. Matthew, you do 2 out of 3. Curtis, you do 2 out of 5. Okay, give me the decimals. We'll start with Vincent. Wait, stop. I'm recording. Yep.
It's 0.6%.
0.6. Okay, hold on. Okay. 4 out of 6 is what? 0.66 repeating. So we're going to say 0.67. 5 out of 7. 0.71. 2 out of 3. 0.67. 2 out of 5. 0.4. Ladies and gentlemen, now on a serious note, what do you guys notice about this percentage?
Around 70%.
Okay, we do have one that's kind of off, like only 40%. But could I safely go to Mr. Duck? Okay, at this point, remember, I need people to be quiet. Do you think it'd be okay for me to go to Mr. Dull and say, Mr. Dull, I think we're safe to say that 65% of the school is going to like pizza. Do you think that would be a safe number?
Yeah.
Okay. Now, in all reality, in the real world, okay, there's no way I'm necessarily going to know the exact percentage of how many people love pizza. Yes, I could put it on Schoology. But the issue with that is people who only really like pizza or really don't like pizza are going to respond. People are like, we're not going to necessarily know, right? That's called a voluntary response bias in statistics, and that causes a lot of issues. American Idol, Dancing with the Stars. When the guy says, America has voted, well, that's not true. America hasn't voted. People get really excited about a candidate vote, and they vote over and over and over again, okay? So there's an issue with that. That's why we don't put it on Schoology. I'm going to randomly sample people, so I'm going to go randomly find certain people, and I was pretending you guys were my random sample. A random sample is going to give us a better result. Now, the issue with statistics is things vary. And Mr. Dahl asked me a question about the entire senior class. I can't tell him for certain it's going to be 60% or 67 or 71 or 67 or 40. So what we do is we build a margin of error. And that's the learning target today. We say, I think it could be 60% of the senior class will like pizza with a margin of error of this. Meaning it could be on one side or it could be on the other. And that's what we're going to get into tomorrow, building an interval. But today we're going to just do the margin of error. And we're going to use what we call the simple method. And when you get to AP Stats, we get to the more complicated method, which is still pretty simple. But we're going to, since you guys are in 9th grade, we're going to just stick with this method for now. And I only have 2 slides over it. So let's get going. Did that make sense why we need a margin of error now? We see that statistics vary? Yes? Okay, let's go. Let's go. All right. So we have one question on this slide. Your learning target again is, I can compute a margin of error and find a sample size. A margin of error is equal to m, we say, and m is equal to plus or minus 1 over the square root of n. This is the main form, or one of 2 formulas you need for today. If you took intro to stats, this is the margin of error we use for the first semester. You won't take intro to stats in here, you'll take AP stats. But it is used in intro to stats books, just so you know, it's not just a whatever type of margin of error. It's not made up. Thank you. That's the word I was looking for. It's not made up. If you're curious on what n is your sample size. So how many people we are interviewing. And I only have one question on this slide. This is what the first page of the homework will be. If your sample size is 250, what's your margin of error? What are we going to do? Do you think I need to write steps on the board? No. What am I going to do? I'm just going to plug 250 in. So I'm going to say m for margin of error is equal to plus or minus 1 over the square root of 250. Can you guys type that in your calculator for me? 15.8. So my margin of error is equal to 15.8.
No, wait, never mind.
Yeah, why is there a number on top?
Yeah, there has to be a 1 on top. So did you?
It's not 15.8.
Okay.
0.063.
Yeah, 0.06.
That's just the
Okay. That's okay. So a mistake was made. It's no big deal. It wasn't really a mistake, but the answer that was given to me was just the square root of 250. The square root of 250 is 15.8, right? Is that what you're trying to say? So what we need to do is we need to do 1 divided by the square root of 250. And 1 divided by the square root of 250 then would be what?
0.00.
Okay, so m is equal to 0.063. Okay. Thank you for saying that. M is equal to plus or minus 0.063. Okay. Now, I've been keeping things in decimals so we can keep our margin of error in decimals. If we were dealing with percentages, then we would change this to a percent. In AP Stats, you'll keep everything in decimals, so I'm going to leave it in decimals because I just want AP Stats to be a natural progression for you guys. And that will happen again next year when you guys take pre-calc and so on and so forth. Questions there? I don't know who is next year, but let's move on because we're taping and we can talk about it later. No, I'm not. Don't jump for joy. I'm just kidding. I'm just kidding. Okay. In all honesty, though, I want to just get a gauge. Thumbs up. Can we move on?
Yes.
Okay. So we talked about the reasoning to why we need a margin of error with our pizza example. Well, now sometimes we want a small margin of error. And we want a small margin of error so we can be pretty precise. Because in the big-time businesses, when they're using statistics to make decisions, they don't want a big margin of error. Because then they're like, well, wait, there's a big range of what it could be. Could it be 40% with a margin of error, or is it 60? Where am I at? We don't like a lot of variation in statistics So we like to control the variation. We like to control the variation. We like to control the size of the margin of error. And in order to do that, we need to find a desired sample size. Okay? And we want a margin of error of 3%. That's kind of standard in statistics, like in the political arena. 3% is a standard margin of error. So in order to control this variation a little bit, we say, well, how many people do we need to interview then, or sample, so we get that margin of error of 3%? Okay. Now these do have some steps. They're, in my eyes, easy steps, but we need to write them down real quick. Keep in mind that your M stands for margin of error and your N stands for sample size. What kind of ball am I dealing with right now? Oh. No, I kind of figured, but. Okay, so first step that we want to do, step 1. Do you notice I have it in a percentage?
Yep.
Do we ever work with percentages in the calculator?
No.
No, we work with decimals in the calculator as a percent. So we need to change the percent to a decimal. So 3% as a decimal is going to be what? 0.03. So M is equal to 0.03. Then what's our second step and our final step, really? Well, we square it because we're going to plug it in, right? Yeah. So plug into the formula. And evaluate. All right, so we have N is equal to 1 over 0.03 squared. And in statistics, we are always going to round up. Okay? We are always going to round up. So how many people are we going to interview?
Less than 5, so we probably should do those.
Okay, so no, we're always going to round up, no matter what.
12.
So we get, I need to see someone having taken the calculator. So it's going to be 1,112. Based off my calculator. Type it in all at once, okay? 1,112 people or entities or whatever. So today, let me just kind of summarize and I'm done. The goal of this was, first, why do we need a margin of error? We need a margin of error because statistics vary. And so what we're going to do is we're going to build an interval to go to Mr. Dahl and we're going to say, hey, Mr. Dahl, I found that 65% of the people I interviewed love pizza. But if I did it again, it could be different. I'm not going to do it again because that's taking up way too much time. So I'm going to build a margin of error. And I'm going to say I think it's 65% with a margin of error of 3% or whatever we get. So then Mr. Dahl has an idea of what it could be. Well, then Mr. Dahl says, well, wait, I want you to for sure ask this many people because the margin of error you gave me was too high. And let's say he set it at 1%. Well, then I would know how many people do I have to ask to get a margin of error at 1%. So that's the goal of the second slide, why we need that. I'm done, unless there's questions. All right, you guys, I'll pass out your worksheet.